Hi, in this video, we will talk about Fibonacci sequence. The Fibonacci sequence is a simple sequence of a number that appears in many places of nature. It was named after Leonardo of Pisa or Leonardo Pisano, also known as Leonardo Fibonacci. This was first introduced in his book Liber Abaci, or the Book of Calculations, in 1202. The series of numbers starts with 0 and 1. The series goes 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. Now, this is the Fibonacci sequence, and its terms are called the Fibonacci numbers. The Fibonacci sequence has this formula: x sub n equals x sub n minus 1 plus x sub n minus 2, which means that the next number is found by adding up the two numbers before it. The 2 is found by adding the two numbers before it, which is 1 and 1. So 1 plus 1 gives 2. The 3 is found by adding up the two numbers before it. Looking at the series, the two numbers before 3 is 1 and 2. So if we are going to add 1 plus 2, it will give 3. The 5 is 2 plus 3. The 8 is 5 plus 3. 13 is 8 plus 5. And 21 is 13 plus 8. And the same process repeats if we are going to get the next numbers. How to get the next number in the Fibonacci sequence? We have to add the existing number and the previous number. For example, the next number in the sequence above is 21 plus 34. By adding these two numbers, we will get 55. The next number is 34 plus 55, and this will give 89. And here is a long list of Fibonacci numbers. Fibonacci sequence makes a spiral. When we make squares with those widths, meaning we are going to use these numbers in making squares. Square with the width of 1, with the width of 2, 3, 5, 8, 13, and so on, we get a nice spiral, which is known as the golden rectangle, which is known to be as the perfect rectangle. Look at this image. We have a square at the center with the width of 1, and another square with the width of 1, and then we have a 2 by 2 square, we have a 3 by 3 square, a 5 by 5 square, 8 by 8 square, 13 by 13 square. Then we can make a spiral out of it. A golden rectangle can be broken down into squares the size of the next Fibonacci numbers. If we were to take the golden rectangle, break it down to smaller squares based from the Fibonacci sequence, and divide each with the arc, the pattern begins to take shape. We begin the Fibonacci spiral in which we can see in nature. So this golden rectangle or the Fibonacci spiral can be seen in nature. We can see this in our fingerprint. We can see this in the egg. We can see this in our face. And we also have here other examples where we can see this Fibonacci spiral in nature. We can also see these Fibonacci numbers in flower petals, which exhibit Fibonacci numbers. So the number of petals in these flowers shows Fibonacci numbers. 1 petal, 2 petals, 3 petals, 5 petals, 8 petals, 13 petals, 21 petals, 34 petals. This number of petals are Fibonacci numbers. We can also see this in the sunflower. The sunflower seeds conveys the Fibonacci sequence. The pattern of two spiral goes in opposing directions, clockwise and counterclockwise. The number of clockwise spiral and counterclockwise are consecutive numbers in Fibonacci numbers, usually 21, 34, and 55. The image on the right side shows 21 seeds. The image on the left side shows 34 seeds. And at the center, it shows 55 seeds. Fibonacci sequence can also be seen in the way three branches form or split. A main trunk will grow until it produces a branch, which will create two while the one lies dominant. The pattern of branching is repeated for each of the new stem. Look at the number of branches. 1, 1, 2, 3, 5, 8, 13, and 21, which can be seen in the Fibonacci numbers. Fibonacci numbers can also be seen in the growth of rabbit colony. The table shows the number of pairs of rabbits on the first month up to the sixth month. Total pairs of rabbits at the end of the month are 1, 1, 2, 3, 5, and 8. And you have noticed that these are Fibonacci numbers. The sequence encountered in the rabbit problem 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, and so on, it's called the Fibonacci sequence, and its terms are the Fibonacci numbers. That would be all for today. I hope you learned something. Thank you so much for listening. Bye-bye.